Welcome, everybody. Drake's Lounge, and October version. Um, let's see. A couple of things from Sarah. Uh, we did have Ken Redcap and Tom Hagen. We accepted an appointment, was approved by the board to be the co-education chairs. So you'll start seeing their name pop up every once in a while. So if you got a speech you need to have, a Sarah representation, you got a class that you want to have taught, something like that, see those two and see if they can help you out. And also, Tom Jacobs and Donna Halen are continuing to turn over with Brian O'Rourke for treasurer. That's a pretty long process, and so at the end, what will happen is Tom's the treasurer, Donna is the assistant treasurer. We found that especially during the conference times and the membership renewal times, which is April, August timeframes, the amount of traffic of 400 people going to those two, or going to one person, was just overwhelming. And just that's all you do. And this is not meant to be a full-time job. So we got an assistant treasurer for the first time, and assistant treasurer is probably going to handle most of the membership, the quick reaction membership emails, and have the treasurer being the official, guardian of the accounts and things like that. And between the two of them, they should be able to reduce the amount of hours. I think Brian was saying he's putting in 5 hours. His days he's put in 5 hours on just Sarah during those times. So we want to. This is not meant to be a full-time job, and our pay isn't very good, by the way. Let's see. On the YouTube channel, we just went over one of the marks in the YouTube channel is to get monetized, and that's thousands within 1 year. You got, well, let's see, total of 1,000 subscribers, and right now we're at 1,069, and for the last year having over 3,000 hours of viewing time. So imagine our little organization here. We've had 3,000 hours of all those YouTube channels of, without us being involved, having 3,000 hours of amateur radio astronomy being presented. So I think that's and it's just going up right now. So I think in terms of representing the amateur radio astronomy community, providing information and content and education, I think we're on our way to really making an impact on the community. Let's see. And by the way, the monetization is we're looking into that. There's some glitches in terms of the account. Chip owns the account, and if it goes to him, and how do we work the money if we ever get it, and things like that. So we're not accepting the money from YouTube yet, but it looks like we might be able to start trickling in some money from the YouTube account. And what they do is they give you a small percentage of the advertisement they get from that. So we might have another source of income for Sarah with that YouTube account. But I would say we have to work out the financials, taxes, and all that kind of stuff issues. Let's see. The journal will be out this week. I think it's the largest journal ever from Sarah. We're over 160 or so pages now. And for the guy, and thank you everybody for the reviewers. The board reviews it before it goes out. Sends me a lot of good tweaks and stuff. And by the way, you guys, I actually got another article since I sent it out to you guys. So there's one more article size that even from when I sent out to you. So that'll be out by the end of the week. Let's see. Sarah Western is let me see real quick. He's not on. Okay. The Sarah Western Conference is going to be 9 April in Dallas, Texas, University of Texas, and 9 April in Texas, in Dallas, is a total full eclipse. Okay. And so that's the plan for the Western Conference, is to do the total eclipse. See the go to the website. He's got the information on there with a couple of hotels and things like that to check in. And so it looks like that's going to be the plan. And it's just going to be pretty fun. Just been notified by ARRL. Remember we were working on that antenna book for the last year? Well, it's finally going to be out. If you were an author, by the way, and you have not gotten contacted by the ARL committee, check your spam folder, because they sent out a notice to the authors, and they're going to get you. They want to verify your mailing address, things like that. You're going to get a free book and potentially some remuneration on funds or something like that. I don't know what they're going to call it. So you might get something like that. So they need some information in order to make that happen. So we started on this project almost a year ago, I think November of last year. We came up with a concept of putting radio astronomy antennas in the ARL antenna book. And we have numerous authors who contributed, and I think it's turned out pretty well. I've seen a couple drafts over the year. But it's a long process. It took almost a year from concept to doing it to actually getting the book. So it's one of those things you just gotta hurry up and wait. And it took us quick reaction to get the papers in line and tune them up, and then we waited a long time. So, but it looks like it's going to happen. I think we are chapter 22. I don't think that there's another input besides the SARA organization in the radio astronomy antenna side. Let's see. Okay, so some things to talk about today. We obviously had the eclipse yesterday in the U.S., so I want to see if anybody was able to see anything with that. I've seen a couple things about Radio Jove seeing it. When it happened in 2017, I saw my Super SIDS. So if anybody had a Super SIDS and you haven't checked your yesterday's Super SID files, go check them, because you might actually be seeing the eclipse in there, and it looks just like a triangle. It's not a fishtail thing. It's more of a triangle-ish thing for that. We also have the 6-meter beacon project, which we started at the Real Drake's Lounge on the Eastern Conference, where they're trying to set up beacons across the U.S. So they're trying to develop a beacon that we can use instead of the analog channels. And the goal here is that SARA will be the provider of the beacon, the 6-meter beacons, so that the meteor observation people will have something to, the bistatic bounce to see off the meteors. Okay. And Lester's been working on that, and there's been a lot of chatter on that. So anybody wants to talk about that, that's great. Let's see. There's also been a lot of discussion on interferometry, specifically what type of SDRs, dual channel SDRs, would work with interferometry. So got a few people online to do that. Let's see. And I think, Ted, you've had the interferometer, your interferometer project that you showed, and the shoes project going on. And Wolfgang's actually got a guest. But first I'll go to our probably our most time zone sensitive person, and that's Dimitri, who also gave a big observation report for the journal, which you'll see when it comes out at the end of the week. So Dimitri, what do you got?
Hello to all. I'm glad to see you. I don't have any message for today.
Okay.
And I have not good news for today. I am forced to dismount my dish mm, uh, 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 and but all system, including dish, will be stored and pack it and store it in a dry place. I hope to find a new place for my system, at least for several months. But I have I have many things to talk about and to write about in the journal, like descriptions of uh, my receiver and software, uh, mm, maybe uh, experiments with um, lunar and solar measurements in millimeter waves, uh, and noise figure measurement, precise noise figure measurements using cosmic microwave background. This was some works was done uh, uh, 5 or 6 years ago, and I can I can speak and write about. For now, I think for it at least next in next months no any major observations could be expected. Or, so I just not very good news. So thank you.
All right. Well, thanks for your article is really good, and you guys will see that when the journal comes out. Okay. Well, thank you. Let's see, Wolfgang, and I don't know what you have. You have a guest, and you have and I don't know if you have anything else to present after you introduce your guest.
Yeah, maybe I introduce Vanessa Schulz today. Obviously, she can talk about herself in just a moment. She joined our organization just some time ago, and she's a student towards Master of Astrophysics. And maybe I turn it over to Vanessa to introduce herself.
Yes, thank you very much for letting me join today. My name is Vanessa and I'm 22 years old. And as Wolfgang already said, I'm studying in the master program towards the Master of Astrophysics. And I'm also, based on radio astronomy in my master's. And I'm, working towards my master's thesis. And I want to write it at the Astropeter in Stockholm with Wolfgang, if that's possible. And yeah, thank you.
Great to have you. Always invited, by the way. Go ahead and sign in anytime. All right, go ahead, Wolfgang. You lose him.
Okay. Well, I'm not sure whether we have the same audience as for the RTOP recently, where I showed a few slides on the experiments for interferometry that I have been doing jointly with Vanessa. Just to repeat that in brief, we set up maybe I share the slides so it's easier to talk about then. Let's see. So I hope this is coming up.
Yep.
Okay, I had already shown that at our last meeting, the RTOP 2 weeks ago. Essentially, it's fairly simple proof of concept kind of thing that we did. We set up 2 antennas, or we call it stovepipe antenna, on a tripod with an LNA. We made a mistake originally when we set up the baseline at 15 and 30 meters. That's actually too wide, because then the fringe spacing gets smaller than the sun diameter. So we more recently changed that. It shouldn't be more than 10 meters. The rest of the RF chain simply consisted of a cavity filter and a SDR. Originally, we used the Lime SDR, which is a dual channel device. But recently, we also tested the dual channel version of the Ada and Pluto. Those of you who are not familiar with that, the Ada and Pluto originally is actually designed as a single channel device, but the chip inside has dual channel capability, and the more recent hardware versions, they have the channel exposed on UFL connectors on the board, so you can easily get to that. So we use the Ada and Pluto. That works also okay. Essentially it's same as with the Lime SDR. You may know that the Lime SDR itself is no longer available. So the Ada and Pluto, the current finding is yes, it can be used as a dual channel correlator or for any dual channel purposes. So that's what we set up. This is originally the too large baseline, 30 meters. This was the first setup, but then we made it more close. And these are fringes. The basic purpose of this exercise was, can you actually see the sun on the sun fringes with very small aperture antennas? It's a stovepipe, which essentially is 15 centimeter in diameter. And the answer is yes, you can see it. There are some things which we are working on to understand. So that's some preliminary thing that we did. And we're looking forward to some more experiments. Actually, this afternoon we also did some experiments, and yes, the sun is still there, and you can see it no matter whether the sun is shining or not, or whether it's hidden by clouds. It's always showing its fringes. I guess that's a quick one. Those of you who have already seen it, my apologies for repeating myself.
Did you guys try it during the eclipse, or did you guys even see the eclipse?
No, we won't be able to see it. Well, we didn't. It was not in our place, so otherwise we would have certainly looked at it. There was a discussion on the Zara forum. Somebody was asking the question, "Can you see the solar eclipse?" And I had some data from last year, almost a year ago, October of 22, when we had a partial eclipse, and when we recorded it with a 2-meter dish, total power recording, not an interferometer, just total power, and you can actually see the eclipse. Interesting point with that, maybe just to mention, we had a decrease in total power of 20% in the maximum, and the visual coverage is also close to 20%. I should mention that actually at L band, the sun diameter is a bit bigger than the visual diameter. And what we saw, I think, if I recall correctly, was that therefore also the solar eclipse started a bit earlier than the visual eclipse and also lasted a bit longer. But the coverage and the attenuation was 20%, similar to what you have in visual.
All right, thanks. Anybody got questions for Wolfgang? All right, and Vanessa, what's your thesis on?
If everything works out, maybe M81 and M82 and the connection between those two, because there's a material flow, and maybe we have a chance to see something more, or yeah, we'll have to see.
All right. Well, good luck to you, and you got the best sponsor you could find with Wolfgang. So
Yes.
I think you're going to do great.
I have
Okay.
Thank you very much.
I have a question for Wolfgang.
Go ahead.
Yes.
Your recent conference, is that going to be, are the presentations going to be broadcast anywhere? Or
Well, we have the slides online on our website, and it's not sure whether we can put the videos. We took a video recording, and I'm not sure yet whether we can publish that. I'm looking at it from two aspects. First of all, I need a video editor, somebody who does the editing of the video. Rich knows what that means because he's
Well, I
done
can
it a
help you
couple of.
I can help you if that
Yeah.
were if that's the issue.
Yeah.
Yeah.
And also, we need to clarify that everybody gives us permission to have that put online. I do have the permission to put the slides online. You can find them. And on the video, I have to find out.
I looked at the slides, and I hope that we will be able to see the presentations. Thank you.
All right. Yeah, Wolfgang, I can help you on definitely on the videos if you need it. Okay. Let's see. Ted. So I sort of follow up on interferometry and the shoes project. If you've got any updates on your stuff.
I don't think we have any updates on shoes. That was the idea of sharing data for places you can't see because the Earth is in the way. The shoes is up there. I could post the link to the page in the chat in just a moment, but I think that's it for that subject. I've been working a little bit on my interferometry, trying to see if we can make an introductory interferometer for folks just want to explore it, and I'll show a couple of slides. Let's see. Share. No, I gotta hit this button. Okay, I hope that's coming up. Let's do this. I'm trying to do this with cheap antennas. This is that PZT for PVC pipe and zip tie antenna. I can make more of these. I made 2 of them, and I put them 2 meters apart. Like last time I showed you, we got an interesting interference pattern. The envelope we determined was the shape of each individual or one antenna beam width across the sky, about 30 degrees at the halfway point, half power point. Okay, that's nice. This was with spacing when they're 2 meters apart. The math works out, it all looks good. If you put it at 3 meters apart, you can see it's a little bit tighter fringe spacing. We get more fringes inside that envelope, as expected. I'm just proving things. Let's move it to now 4 meters. Okay, now we get more fringe patterns. And I'm starting to run out of room. I wanted to see if it is repeatable. So I went back to 2 meters, and sure enough, it was just like before. Okay, well, then I got busy in hardware, and I made 3 of these things, or another one anyway, and put it over on the right. And so what does that look like? And it's interesting. We get some kind of weird interference pattern. It looks like every other fringe has been minimized. And that's when the big winds came over and blew over the 3rd one. So it has now been replaced and is recording data at the moment in a new position. So I'll try different combinations and see what I get for interference patterns. What I'd really like to do is null out a whole bunch of things except one in the middle, and that would effectively reduce my beam width of the antenna system. I'm not sure that's going to happen, but it would be neat to see what goes on. This is a very simple adding interferometer where I just take the hots of the coax, the center connectors, and short them together for a combiner. That's pretty crude, but it's pretty simple and can be explained to others who want to give it a try. That's what I have. Any questions, comments?
Yeah, maybe I have a question. It looks like you had your 3 antennas with equal spacing, correct?
2 meters and 2 meters, right.
Yeah, okay. So then you would expect that one of the fringe patterns even or cancels out.
That seemed like the simplest experiment to do first.
Yep.
You
Yeah.
You were suggesting put the third one in some weird place that is not some multiple or fraction.
Yep.
And what will happen then?
Yeah, well, you will get an different fringe spacing, and there will be one location where all fringes come together, and that is sort of the maximum or the pointing direction.
Okay, that's what I'm hoping for. But I thought I'd do the simple experiment first.
Yeah.
And then time and life got in the way, and then the winds came and beat it up. So that's the experiment today. Look forward for new results. Thanks.
Now I also got a question, Wolfgang. The total power is going up over time on this thing, and Ted, the book I gave you from Lonk actually recommended some kind of adding a 90-degree phase cable, and he was just doing 2 antennas, but a 90-degree phase cable in one of the antennas. I think it was the obviously the farther one away, to reduce that, to make it flat. I don't know if any of you guys have ever heard of that before.
Are you saying flat on the bottom side?
Yeah, so it's not. You notice how the whole thing's going up.
Oh,
over time.
that's just temperature drift.
Well,
This was
I
the
mean,
best plot I had. It
Right.
happens.
No, I understand, but I think what he does, look in that book. I think he says that if you put a 90-degree cable in there, 90-degree phase cable in there, it'll flatten the whole thing out, even with a temperature drift or whatever. And I don't think that's temperature drift, because I think it's some artifact of the measurement. So, but he describes that exact output you got, and he had a solution for it.
I'll take a
Flatten the whole
look.
bottom. Yeah.
I see temperature drift in other plots. These were the good days where it was rather flat.
Okay. All right. Well, this is really good stuff for 3 PVT antennas, I guess. Okay. And I guess the next,
Can I make a comment here?
go for it.
Okay. If you look in Krauss's radio astronomy book from ancient history, way back, I guess in the 1970s, 60s type time frame, somebody built what they call a grating interferometer, where they had a whole bunch of antennas spaced just on the same basis as his 3, but there was a whole lot of them. And as you get more of them, you get a series of lobes, and they managed to set this thing up so the series of lobes resulted in the lobes being a little over a half a degree apart. And the advantage of the half a degree apart was that they were, looking at the sun with it and wanting to see, hot spots on the sun. And as the sun would go through the pattern of this interferometer, it would go through one of the lobes, and it was small enough compared to the pattern that it was only in one lobe at a time. Then it would go through the next one. So you'd repetitively see the sun over and over going through that. So it was used for solar studies. And it is in Krauss's book. If somebody wants, I can even look up the page and get back with you.
Tell me the magic word. Is it grading, like grading a road?
Grating, Grating, I think is how it's spelled.
As if scratching. Okay.
It's just like an optical grating. You got the optical gratings that are used sometimes in optical spectrographs instead of a prism. And there are a whole bunch of very fine precision lines scored on a plate of glass. Well, yeah, it's a grating. Well, this works the same way, except that it's with radio waves, where you have a whole bunch of antennas spaced across, and gets the same effect.
Oh my, I have to build more antennas. Okay.
Like a diffraction grating.
Yes, same word.
Yes.
Bruce,
you for all the good thoughts.
Is that in Krauss's book, Radio Astronomy, or in one of his other books?
That's in the radio astronomy. I'm going to go ahead and grab the book off my bookshelf. It's only 15 seconds away from here, and I'll find the page and show the picture here, so the front of it, so people can see.
Excellent. Or put in the chat. Yep. Anyway, my simple experiments continue. I'm confusing my neighbors. Thanks,
I was looking
Rich.
for my book. No, thank you. I have my book back here somewhere, but I couldn't find it real quick. Okay. Thanks, Ted. This is really good stuff. And let's see. Let me find my list here. Let's see, Alex.
Well, good afternoon. My presentation may not be as technical as some might like, but I'll start this presentation. I got some data from Preston and Charles this week, I guess, and I did some processing, and it opened up an interesting idea for LSR correction. You see it? Working?
Looks good.
Okay. All right. So I just put this together, I guess, yesterday and this morning. Way this started was Charles gave me some data, and I started processing his under the same software that I had been using for my own, and looks pretty good. Here's one at plus 36 degrees, and it has a little bit more detail than I can get with my 1 meter, and it should. Here's another interesting one at minus 30. Quite a bit of different response that low, sliced through the Milky Way. Both of these are 24-hour cycles, and I think we're running. I think he used about 4 minutes per average. I'm not sure which one. We changed it around, but so this is what I got from Charles, and this is using SDR Sharp software with IF average, the plugin. And this is the one that was interesting, is I got some data from Preston, and it's from a Spectra Cyber. And we never figured out what the vertical scale is. If anyone can decipher it, let me know, because it's in volts. And this scale runs from 0 to 8 or 10 volts, and it makes no sense. But I didn't get a frequency scale, but I processed it with just raw data. So the process being pretty much the same, define a frequency where you want to normalize the amplitude drift, sort of diamond there, and then I plotted this as a surface plot. And we split that up into 2 time periods, and I got some interesting results from that. But that brought up the thought is there a way to create some type of an estimate of LSR correction with not having all the information, not knowing where it's looking, the time that it was taken, the location data, but just some type of processing that would allow me to create some type of an LSR plot, and remove some of this drift. This is my data again, and this is typically what a drift looks like. And using some software I got from JJ Mantois, quite a complicated program, it does this. And I'm sure I pose the question, is this even normalized correctly? Because this one crosses over about say -5, and this is +5 kilometers per second. I don't know if this is correct or not, but this is a very involved process. And comments? No? Okay. Anyhow, I did another process, and I came up with this, and it's very simple. And the idea is, in fact, I'll take a look at these. It's not that different from the complex correction, but it has some limitations. But the idea is to take for each slice, each sample, find the peak amplitude and subtract that out. Basically, shift the velocity files in that array to bring them back to 0. And so if you do that, you wind up with this. And so that was the process. And so I could do that. Whoops. Yeah. So that was the process, and that's what I did with Preston, and I got a, whatever it is back here. Yeah, I got some type of a scale. It's not scaled in velocity, could be, but whether that is really a valid estimation, I'm not sure. There are a couple other iterations on it, but it was one fairly simple way of normalizing the drift.
Well, I have a question, and the question is, I assume the bottom scale is right ascension in hours, and it looks like the two sites are 180 degrees different from each other.
Well, more or less. Oh, then that's going to depend on the declination. But I mean, these are, yeah. I mean, you're slicing. It's like a baseball or something like that. You're making some weird slices through the Milky Way. It's not. It isn't clean. Let's go down. Let me show you something else. This is the next iteration is to use JJ plot here. So it depends on where you're looking as to what part of the Milky Way you slice through. And that one that I was looking at plus 40 degrees gets this hot spot and almost gets over here in the galactic longitude.
Okay, so they're two different objects, but it's basically slicing through the Milky Way.
It's a 24-hour
direction than the other.
Yeah, just a regular 24-hour drift. Antenna fixed, guy moves by.
I find it very interesting. So thank
Mine
you.
online.
Alex, maybe a few comments. First of all, I mean, calculating the local standard of rest as long as you know where you're pointing, this can be calculated. And I think these days you can use AstroPi for that.
I got kicked offline, Wolfgang. Would you back up about 30 seconds and repeat your comment, please?
Yeah, I said if you know where you're pointing, then of course the local standard of rest correction can be calculated. One way of doing it, or the most straightforward these days, would be to use AstroPi. I wrote an article about how to do LSR correction some time ago in the Sarah journal. So if you look there, it gives you the background and also gives you a link to a code to do that. And there's also another code by Jan from, I forgot his last name. Jan Tamodijkma, I think is his name. He also wrote some code to do that. And if we compare that, they're very almost identical within fractions of a kilometer per second. The other, so if you take this here, what you're showing, you know it's 40 degrees declination, and then you have the right ascension, so you can calculate it. When you don't know where you're pointing, I think this was what you were showing from Preston's data, where you didn't quite know. That you made the assumption that the when you have the passing of the galactic plane, where you have the highest intensity, that you're looking at something that is pretty much zero zero velocity. You could check that assumption by looking at the survey spectra, where you can, for example, from the University of Bonn, where you can enter the right ascension and declination and see is that a fair assumption that it is always close to zero. So
it was just something to do with the data, and I know there's a lot of issues of this being actually a valid approach, but at least for at a beginner's level, it does give you a corrected spectrum, or a more of a corrected sweep.
Yeah, the hesitation that I would have, you're throwing in an assumption, like the brightest is always at zero,
And it's not.
It's not always. That's what I'm getting at. It can be the case, but it's an assumption which is not always valid.
All right, let me show you the rest of the story. I realize that, and what I did here, I went through and I haven't processed, but I did a guess of what the maximum might be if I used my process of just picking the peak amplitudes, and it winds up with errors like this.
Yeah, this is what I was getting at. Yeah,
there could be, and I haven't tried this. I haven't done anything with this, but yes, in these bright areas, the answers are really good. You get over into some of the other areas of the Milky Way, and there could be huge errors. That was the next process I was going to kick around and see what I could do. But it shortens the script up to 2 or 3 lines of code.
Alex, what was the question about the Spectre Cyber data?
What are the units? What are the vertical units?
Okay, they're in volts.
But what does that mean? That doesn't mean anything.
It's
is it volts squared?
It's interesting. It's a linear. Oh, I see what you're saying. We had this discussion about volts squared versus volts.
Someone needs to stick an attenuator in front of that unit and see how it changes. It changes as voltage or power. I mean, that needs to be defined.
Well, the other thing that's interesting is, in order to keep it in that, it easily above 10 it saturates, so it goes flat. So you have to change the gain settings on the on the software, and so when you get data, sometimes you need to figure out what were the gain settings on there, because it could be twice the value of another data set you got, but since you had the gain settings set down so you can get less than 10 volts for the peaks, you don't know what the total is.
Then you can never convert that into a dB level versus cold sky if you don't know what those steps are.
I think that's the issue. I always have to. Sometimes I would have it and it would saturate, and I'd get the whole thing would be flat on the top, and sometimes it'd barely peek over the background, and I have to change the gain settings in order to get it into a fair margin. So yeah, I don't trust that unless you put a calibration before and after the observation.
That's why I didn't try to convert it. I just used. It gave a nice plot.
I'm afraid I have to make my usual comment. Don't ever use dB in radio astronomy.
It's a way to create a basis upon which you can improve or adjust your telescope. It may not physically represent the environment, but it is a way to compare one configuration of your telescope with another.
Now, you typically want to have let's call it the intensity, essentially the received power. Of course, you can describe the power in dB, but in radio astronomy signals, the variation of the signal is so small that it doesn't make sense to use dB, a logarithmic scale. It makes a lot of sense in communications and so on when you have a large variation over a large variation in power. But if you look at publications or whenever people say something about the intensity, they either express this in brightness temperature, which is essentially also power, or they express this in Jansky, which is also power. So, and you do it linear. Linear power, whether it's expressed in Kelvin or Jansky, is typically what people use.
Let's make a comment. The step attenuator you probably have in your lab is marked off in dB. And the first thing you need to do is take the dB and convert it to true power ratios.
Yeah. Now, essentially what I'm getting at, if you show some data in radio astronomy, I would strongly recommend never show it in dB, which is sort of a logarithmic scale. You rather show it in a linear power scale. It's much more meaningful from a physics point. But anyway, coming back to this this question of spectra cyber. So if the manual doesn't tell you whether that is the scale is linear in power or whether it's linear in voltage, then indeed you just need to test it. Put some test signal on it and change the power and see does it follow linearly or does it follow in a quadratic. If it's really voltage, then it would be quadratic because it's the power is voltage squared. And that can easily be tested.
Rich, I think you finally decided that volts out of a spectra cyber was a measurement of relative power, and forget.
Yeah, I think that's right. And the other thing I did not explore was the fact that it was all relative to its other measurement, but I don't know if you can. We didn't try to do any exact absolute measurements with it. The other comment I was going to bring about spectra cyber is that you can also adjust it in frequency, the center frequency being 142406 megahertz. There's an adjustment for frequency on that thing, so that and what I had done was to put a 142406 source near the antenna, and then I calibrate it, and then you can move the baseline to 0 on that thing, so you can calibrate it in frequency. That's also possible with the spectra cyber, and if you're going to accept spectra cyber data, that might be one of the questions you ask: was the center line set for frequency also, as well as the gain settings on the amplitude? So. But I never tried to do an amplitude chart except for relative, only because it was so hard to calibrate on the absolute side.
The spectra cyber is so old, it was talking more about mechanical strip chart recording. And so that would simply be measuring voltage. And I think that's where the term came from. Alex, to you.
I was just asking, is there any advantage to continuing to use a spectra cyber, even though they're $3,000 or $4,000?
No, I would say it was easy to set up before the SDR showed up, but now with the current setting you got there, there's no way I would jump in with a spectra.
Just a huge jump in technology in the past decade or something.
No, I wouldn't even touch. I mean, I've got one sitting here that I haven't had turned on for a while. It's very easy to set up, very easy to see the plots, and as Ted knows, when I start sending him the data, it's a sort of a mess, as you're seeing too.
Well, it's kind of limited. It has less of a bandwidth than the $35 SDR, and it's slower. Remember, it's a scanning frequency measure. And so you are actually getting different frequency measurements across in time. It's doing the best it can, but it's old technology. Hooray for what it did. And it was nice that it had the receiver and everything else inside. It was great for education. But technology has really marched along.
$35 versus $3,500.
Right.
Well, you can't even buy them now except used. So, yeah.
I think what Ted just said, it's exactly describes it. It's a scanning instrument, which was valuable at the time when it was designed, but just technology has moved on, and you do SDR and FFT, and it's a much different story.
Right. And now you can make an interferometer hydrogen receiver with an SDR, and it blows the spectrocyber out of the water. So yeah, I think we're in the new age. Okay. Anything else, Ted? Or I'm sorry, Alex? Great work.
Maybe just one final comment on the voltage thing, where it might also come from. If the spectrocyber uses a let's say a detector diode to measure, then you get a voltage out of that detector which is proportional to the power. So even though it's a voltage, it actually represents a power, and that's, I'm speculating. I never have seen a spectrocyber in my life, so I'm speculating it, but that may be the reason.
Well, we may ship one to you, the amount of use I'm using with it.
Yeah, we have enough old equipment. We don't need one more.
No, I insist. Okay, no, I'm just kidding. Okay. All right. Well, thanks, Alex. And Preston, since you were a part of this, Alex's input chain, what do you got?
Okay, I really appreciate Alex's work, and I've been tied up. I had my cataract in my right eye blasted with a femtosecond laser, broken up into pieces, and the surgeon took it out, put in an intraocular lens, and I also had LASIK. So I'm not wearing glasses now, as you see. So, but they're still healing. So anyway, that was my project for this week.
All right. Well, that's why you're not an optical astronomer, right?
Right.
All right. Okay. Thank you very much, and hope your eyes are good. Let's see, Wendy.
Okay, I'm on now. Well, now that it's cooled off, I'm thinking about building stuff again. And I'm also thinking of moving and buying equipment. So I sort of wish I had someone around here to make me make a decision. Now, if I were going to buy an equipment rack or build one, I thought I saw something online where someone said, don't build it out of wood. Is there a preferred material to build equipment racks out of? And also, I need to buy some more PCs, and so that's what I'm doing right now. And that's all, I think.
Okay, you guys build a lot of stuff to help Wendy out. What she need to get?
Wish she was closer. I'd give her one.
I wonder what the rack is for. Shells or what? Are you putting spectrocybers in a row?
No, I would be putting just different types of equipment in it. Anything electronic. Like, for example, I kind of hate to say this to this group of smart people, but I have a 2-channel analog oscilloscope, which I love, and it's taking up a lot of space on my desk. And if I get other PCs, I would probably put them in there and just, monitors for specific things. I guess what I was worried about is I saw something about noise interference, and before I spend the money, I wanted to find out if there was some other horrible mistake I could make aside from my regular horrible mistakes. And Charles, where do you live? What do you have? I'll pay, if it's something that's really good, I'll pay shipping.
Oh, it would be expensive shipping. That's the problem. I'm near Winston-Salem, North Carolina. Where are you at?
Dallas, the Dallas area? Although I was thinking, I'm always thinking about moving to the further west. And that's just one of those things. Here where I live, to buy equipment and used equipment is cheap. But then, of course, I would have to move it.
Yeah, I would defer to Bob. He may know of a rack or something. No, what I have is like they're tabletop racks for test equipment. I've got several that I was trying to get rid of at a gathering here just a couple of weeks ago, and nobody took it. I guess they had too many, or it took up too much space. But they're about the size. If I actually use them to put under a desk a lot of times to put my equipment in. So I'll have two racks, one on either side. So anyway, it's expensive to ship those. So there may be a better
I probably have
surplus. Yeah.
I have the same thing that Charles has probably, and I could give you something also. Tell me or think about what size rack do you want. And usually these racks are set up for 19-inch spacing. That's a standard. And for instance, you can get a tabletop rack like Charles is defining. And I've got one that's about 19-inch spacing, that's about 20, it's a shallow depth. And then I think I've got another one that's deeper. It's probably like 32 inches deep, something like that. And it's heavier. Then I got another one that rolls around that's about 6 feet tall. And it's deep and it's very heavy. HP rack. It came originally with fans mounted on the top of it. And all of those are just sitting right now, not being used. I've got two other racks, and I have a lab that I do my testing in that are stand up, and I've got equipment mounted in all those, sort of like the picture that Wolfgang shows. I think he's got a 19-inch rack there also, although he's probably got it in metric terms, but he's got his equipment mounted in that rack. And my opinion is that the rack is probably doesn't need to be RF shielded, because you're probably going to be using coax and things, and your sensitivity to RF signals is going to be removed from the rack somewhere else. And although the racks that I'm talking about that I have are all metal racks. Now there is an amateur radio satellite meeting in Dallas this weekend, this coming weekend, starting Friday and Saturday. And I'm going to be heading over to that, which is very close to DFW Airport. And I think that's over closer to you. And I could take a rack like this over there and meet you if you want to pick up one of them. Just tell me what you want.
Well,
Wendy, I'm just concerned about the definition of rack. Maybe you mean shelves or just stacking them. These guys are talking about 6-foot refrigerator size things that you bolt equipment into as if they were transmitter systems. So define what you want, what you're going to do with this rack. How much equipment do you already have? Wow.
well, I have a lot of audio visual equipment that I've saved from the past. Like I'm trying to get a lot of video stuff on computer. And indeed, the kind of rack I'm thinking of or dreaming of sounds like Bob's 6-foot rack on wheels with the that used to have fans, because that's what I've used shelves and stuff in the past, and I always seem to be moving stuff away from the wall because people to piddle around with the connections and rewire stuff, because it's just beyond my capacity. I don't understand why people put connectors on the back of equipment, because I always have to move it. So I thought, well, I've got like old video recorders and oscilloscopes and other things. I was hoping for 5 foot, but I guess 6 foot is more standard. And Bob, and the other thing is, Bob, I would love to meet you, but I'm still I'm still we're still hiding out from COVID. Neither one of us can take the vaccine, and we haven't been to a public meeting or stuff in about 3 years. So,
Well, let's maybe cut this off here, and I'll just ask you to send me a note or an email, and let's talk on the phone about it. And maybe there's a way I can get you the rack. I'll take a picture of it first and let you see what it looks like. Let's just do it
that sounds,
offline.
yeah, that
I'll show you
sounds,
a couple of options, and I'll be glad to give you either one of them and maybe deliver it to you.
I talked to those used equipment guys you recommended, but I haven't got much further than that because they don't really have pictures. They don't really have pictures of.
You have to go to those kind of places and walk in and pick out what you like based on what they have on hand at the time. And some are only, you can order stuff through the mail from them if you know what you want and they happen to have it. Like I buy these small Dell computers that are available from them I just bought a laptop for $100, a ThinkPad laptop. It seems like it's working great. That I've got Linux and Windows on. They provided it to me with Windows 11, which if I go out and buy that, it's more than the cost that I paid them for the computer. So you can find some good deals if you just know where to shop. You know.
When we lived in Austin, they had this old used equipment warehouse that came out of from people from when they shut down part of TI. And that was a wonderful place to you could just lose yourself in there for a day, wandering around looking at all of the stuff that no one could stand to throw away.
Right.
Okay,
right.
well, thanks, guys. And thanks.
I'll put my email in the chat again in case you don't have it.
Okay.
Great. Well, that's exactly what this was supposed to be, is that everybody collaborate and figure out how to help each other. All right. Charles.
Yeah, and I've got to get out of here because I've got two of my brothers just walked up, so drove up. So now I've got company, and we've had deliveries, all kinds of stuff in the past hour while this is going on. So I have been, busy with a bunch of stuff. Also been gone. I went down to open house at North Carolina State yesterday in Raleigh. So busy with lots of projects, not necessarily radio astronomy, but it's still recording behind me. I wish I had a walk around camera like you were doing out at the Western Conference, because I could walk around in the lab here and show, Wendy, that my rack is similar to what she's probably talking about. I've got a PC and a monitor in there, and so I can kind of move it around because it's got wheels on it. And then, of course, the radio astronomy receiver's kind of in the back. And so it's pretty handy to be able to kind of scoot that stuff around and walk behind it and so forth. And then there's a UPS in the bottom. So yeah, I've got a desk there, but I definitely can't put that much equipment on top of the desk. I've got too many other things going on. So yeah, finding bench space for projects is the latest problem, because I got so many things waiting on parts and halfway opened up, ready to work on. And comment on the journal looks great. Hadn't got a chance to email back to you, but yeah, there's a lot of good stuff in there. Now, if we want to send a copy of that to a student or something, is that okay?
You have, yeah. As soon as I get it out, yeah, I got to figure out Susan's email, but yeah, that's a good idea.
He was going to add one paper to it, though, too.
Oh yeah, that's right.
What?
You were going to add one more paper.
No, I've already done that. It's just I've already made all the fixes. So if it, I'm waiting until Wednesday until I get the last comment in, and then we're good to go. It'll come out like Thursday. Thursday or Friday.
All right,
Takes
good.
long.
Yeah, there's a lot of good content in there that some of the hams that I've run into lately mentioned they were interested in radio astronomy, but they didn't even know about Sarah. So it's kind of a useful segue. Give them a copy of that latest one. It's got so much solar explanation in it that's another good reason to push that one with all the solar flares we've had lately. Yeah.
And if you guys haven't read it, Charles is the one who does the Vintage Sarah article. So check out his article. It's like it's the very first thing in the journal. So he does a great job on that.
Yeah, I know Bruce wanted to flip it so you don't have to go on your side like this.
Well, I did just for Bruce. I didn't want him to crane his neck on that.
It makes it harder to figure out who's who, though. That's what I was having trouble with it being narrow.
You can zoom in. I figured you can. People can't read right, and especially for Preston now. But he's got 20/20 vision now, so he didn't have to do it anymore. So, okay.
All right. Thanks.
All right. Thanks, everybody. Okay. Let me get. Let's see. James.
Yeah, hi. I'm not really doing anything related to radio astronomy right now. I'm trying to get my ham shack set up. It's a very slow process, but I come to the meeting to hear what everybody else is doing and kind of keep up to date. So that's about it.
Yeah, what you do is you spend all your time getting your ham shack set up, getting it and transmitting, and then you'll forget how you did it.
Right.
And so don't take it apart. And if you do, it's going to takes just as long putting it together the second time, which is years later. So
right.
I don't even want to touch mine. It's all sorts of wires back there. Okay. Thanks, James. Ed.
Oh, just listening in and trying to pick up a few things. Hopefully I'll be able to get some things going in this coming year. So
now realize you're competing with Wolfgang for the top number of views on YouTube. Okay.
And every time I listen to that video, I go wrong.
well, we'll get another video then, because right now you and Wolfgang, I have you as the every initial new user goes to your video first, and then if they come back, then they go to Wolfgang's.
Yeah.
So as the first one, and then his keynote address, and then your thing. So I think it's working. We're getting a lot of subscribers in based on those two primary videos. So
I'll give Wolfgang the credit for that.
Oh, you guys are both good. Okay.
Thank you very much.
Bruce, what do you got going?
Okay, hearing me now?
Yep.
Okay. Anyway, we had that discussion earlier on Krauss, and I don't know if people can see this or, well, I can get it in here, but it's that book, Radio Astronomy by Krauss. Second edition, in my case, page 633 has something on the grating interferometer that they used for some solar research way back. So it's definitely interesting reading. If you want to make a whole bunch of those little PVC pipe antennas and, put 15 or 30 of them together or whatever, you could make a grating interferometer. Anyway, the other thing I wanted to talk about a little bit was the Eclipse thing. That turned up to be maybe I get the award for the craziest bad data or something, if there is such an award. But just talking to some people at the Optical Astronomy Club at the museum, and they asked if I was going to try any radio observation of the eclipse, and I mentioned, I'm going to try with my IBT, the small, telescope made from the satellite TV stuff, Dish Network or whatever. But anyway, I'd even made measurements of the moon with that before, which is a considerably weaker source, and thought I was going to be able to take some measurements. And so I got kind of roped in. The museum and says, oh, you could bring your instruments over here and set them up in part of a public demonstration. Well, the weather blasted everything out, so it was a very gray day. You could barely tell where the sun was most of the time. But when I started actually setting things up at the house for my demonstration, I pretty quickly realized I was in trouble because this is made with Dish Network satellite stuff. Well, what frequencies it work on? Dish Network frequencies. If you're it turns up that the solar eclipse from partial eclipse from my location was 2.5 degrees away from the satellite belt. And that was a bit too close. At first, I thought, well, maybe I can live with that. But then I started doing some measurements and I said, oh, no, I can't live with that. So I did some relative power measurements because I do have some stuff to do some pretty accurate relative power measurements. And the typical satellite has a power level of 5 to 10 times what I expect coming from the sun when it's aimed at the sun. So that's a very large power difference. Turned up, I couldn't overcome that. I thought, well, maybe I could catch a few places with between the satellites. And it was predicted to be cloudy, so I added a Altaz positioning system to my IBT so I could find things accurately. Well, it turned up that was no good because satellites are at every slot across the belt there, and the weaker ones are 5 times the strength of the sun. Stronger ones are more than 10 times. I mean, it's just saturating my equipment basically in some cases. So anyway, that was my very botched thing. And then I also had running at home, I've got essentially a 408 megahertz dish feed, a double bow tie or a double quad type antenna with a reflector. And I had that set up so the sun would go through it for the 408 megahertz stuff. And I didn't take a careful look at where it was set up. It turns up when the sun was going through the area of interest, there was a guy wire to my ham tower and a guy wire to the electric company's pole, both in my field of view. So I've got this odd, convoluted interferometer pattern on top of the 408 megahertz. So I can see there's sort of a dip in there. So today I'm running a scan of the sun with the, of course, no eclipse there, and hopefully get the same interferometer pattern and hoping to subtract the two patterns and see what the dip was. So that is going to be, maybe I'll see something, maybe not. So I'm preparing for a little craziness. So life has been crazy with me. Failed experiment after failed experiment. What can you say? And it was an optical bust because I had my optical scope at the museum also, and never got enough of the sun to get the shadow arrangement to line it up on the sun. So couldn't see it. So I got one picture with my camera, just digital camera held up where you could sort of see the sun through. So you can see the sun, an Oreo cookie with a bite taken out of it. So one picture of that. That's my grand total for all of this nonsense so far. So like I said, I must get some kind of award for bad data or something, but whatever. Sometimes you lose.
Well, wait a minute. If I'd given you as a graduate student full credit for finding all the issues with giving these experiments. So you had tons of lessons learned there. So I think that's great.
Well, even worse, I had Dave Westman knew that I was doing the experiment and said, oh, and so he assumed I'm going to do a presentation at the Western Conference on it.
Oh.
So I may do a Western Conference presentation on, how to really mess up your data taking, not plan for things like, hey, the satellite belt is there and you're stuck with it.
Well, I'll tell you what. A presentation like that would save everybody else here untold number of hours if we did your presentation and then we checked all that stuff before we tried to do ours observations. So I think it's a very useful presentation on here's what the possibilities are when you're taking an observation that could affect you from getting the real observation. So I wouldn't discount that as a great presentation.
Okay, I'll get to work on the presentation for the conference there. And that won't be the first thing. Yeah, about 15 years ago, Sarah financed a young lady that was in high school to do something with the SuperSyd thing, and she was never getting anything because of all the sources of interference around, everything from fluorescent lights to, you name it, it was interfering with it. So actually she did a very good science project on, what keeps you from seeing this, all of the stuff in the environment. So I won't be the first one to do one like that, but still I kind of expected to have some real data to show instead of have a thing of showing how to not get data.
All right. Okay. All right. Anybody any questions for Bruce? All right. Bob.
I was just going to comment that for a number of star parties I've gone to over the last couple of years, most of them have someone giving a presentation on their past failures. There's one guy I listened to had something like about been at the location for like 30 different eclipses, and out of all of them, he's only seen like about 2 or 3 due to weather, due to instrument, due to all sorts of things. So a presentation of what can possibly go wrong is definitely a little humorous, and B, it is very, very good information to learn by. Thank you.
All right. You don't think
be able to laugh at yourself.
All these astrophysicists who been claiming dark matter and stuff like that, you think they don't, even though they haven't found it, haven't written up their reports? I mean, stuff like that. So, okay, Bob.
Okay, I've been up to a lot of stuff. I enjoyed listening to everybody here. Ed, I'll tell you that a lot of musicians playing music, you make play a wrong note, nobody out there knows about it. So don't worry about the wrong things that are in the videos. Just keep making them.
I'm not. About 20 years ago, I gave a presentation for an open house. And in the middle of the presentation, I completely blanked out on what the slide was. I picked up my pace again, about 4 or 5 slides later. And for those 4 or 5 slides, I just talked BS completely. And no one, including members of the club, knew that I was pulling it out of my backside.
That's right. Okay, I'm going to share my screen and show you guys a couple of things. Let's see. Hopefully I can share multiple screens here today. I'll share this one first. This is a picture I took yesterday of the eclipse. I had a big party out here at my ranch with about 30 of the North Texas Microwave Society guys, a bunch of hams, and Dave Westman put me up to going out and buying this little solar telescope that we're going to use at the meeting in April. And so I set it up and tried it out this weekend. And this picture, though, I took with a camera. The telescope, I was having a lot of trouble aiming it. But one thing that's interesting, that's a tip that's in their book that could be applied to other people looking at the sun, is the way you aim it is you look at the shadow. And you make the shadow of that instrument as small as you possibly can. And when you get it real small, then you've got it aimed. And if you did that, then you could get it aimed. But then the first person that comes up and looks at it, usually they touch it with their eye or something else. And as soon as they touch it, it's out. So makes radio astronomy look real appealing when you can not have to worry about bumping something like that. But anyway, this is a camera that I set up it was taking an interval exposure. Every minute it would take an exposure. And this is definitely overexposed. But I was so busy helping people get stuff tested or doing whatever they were doing yesterday, and then we had a big feed, that I didn't pay a lot of attention to the camera. I just sort of let it go. But this is what I got out of it. So now if I stop sharing that, and I have a lot of experiments running here, and we're accumulating data yesterday. This is my SuperSyd, and I haven't really had a chance to study any of the data in any detail yet. But just glancing at this based on what Rich said, I don't know if this is the peak you're thinking about or not, but I'm thinking the eclipse was sometime right in this area right here. And this is one of the stations that I'm monitoring 5 stations on my setup here. I don't know what, and that's another question I have, is that what stations are people listening to? I sort of like tried to pick some that were spread out and different frequencies.
The success I had was that the station was on the opposite side of the eclipse, that the path of the eclipse that I was at. So it was north, the station was north, I was south, the eclipse went right dead center between us, and that gave me a beautiful beautiful bump, because it looks like daylight nighttime variation when the eclipse comes over.
Yeah, I think these are noise spikes that are happening in here. And I think there is quite a bit of noise in where I'm set up, or my antenna's picking up a lot of noise.
It looked like a flare. I mean, it really almost looks like a flare.
Much larger. Like this is, I think.
That's possible if that's the eclipse time.
Well, I don't know if the time would be off that much, but I thought this was in like UTC time. I need to go back and double check my times. I guess it could be that big bump right there is the eclipse. But that's what I got to do now. I got to study this data. But I've got this stuff to look at. I've got the ham sci group. I collected data on WWV's transmission with 2 dipoles that are folded dipoles that I've got to study as well. And then I've also got magnetometer data, 3-axis magnetometer data that nobody has written any software yet to take the data, the raw data, and present it in a graphical format that looks nice. And that's something I'm sort of started on, but it's just another big project.
Check with Whit on that one, because he has it. Whit Reeve.
Okay, I'll check with Whit. All right, and then I've got my hydrogen line thing that I've got the antennas all set up and the cables run, and spent some time trying to get the RTL SDRs working the way I want to. I've got 2. I'm trying to set up 2 RTL SDRs, and the little antenna I have has got 2 polarization connections on it, so I'm trying to watch both of them, and I'm real close to being ready to start collecting data there also. So that's all I have.
Great stuff. You got questions for Bob? Okay, Don.
Sounds like everybody here follows Latham's law of horizontal surfaces. Any horizontal surface immediately becomes covered with junk and unusable. And the lowest horizontal surface is the floor.
Right. I was thinking, Don, that everybody should get all of their stuff that they're saving for someday all in one place and take a picture of it, and we could post on pictures of all of our junk. I'd be interested to see, especially for someone like Bruce, exactly how much stuff he has.
Actually, I would need a panoramic camera. I don't think it would work.
Yeah, I'm thinking 1 picture.
Yeah, 1 picture wouldn't do it. Anyway, look on our friend Amazon for hobby shelving and things like that, because most of the stuff we're using now is so small and light that you can get away with almost anything to hold it up. Metal cabinets are great. The old racks, I've got several old racks full of old equipment, and they have to be bonded together with ground wires, and the grounding becomes a real problem. You can get even weird resonances from the inside of cabinets. I don't recommend racks anymore because, as I say, most of the stuff I use much, much smaller and lighter than the 19-inch standard racks. But anyway, that's just I put in the chat 2 or 3 things that have found on phased arrays. A lot of them are for transmitting. Don't let that bother you. Reciprocity works very well. If it's true for a transmitter, the same picture looks good for receiving. There is a formula, and I couldn't find it in my equally junky computer stuff, for if you have a bunch of a bunch of antennas, there's actually an algorithm for locating them to get an optimum beam out of what antennas you have. And it has a name, it has a man's name on it, and I cannot remember it, but it's out there on the web, and maybe a little bit of searching can find it for phased arrays. And I seem to remember they used it for the Australian and South African telescope arrays, these really huge arrays. Yeah. And I know that it's out there, and it'll tell you how to take what antennas you have and tell you what the spacing is for what you want to see. And
or are you talking about the cross, the older cross?
No. The old crosses, those were all equally spaced.
Okay.
Chime
so
and the crosses and everything are all equally spaced antennas arrays. But this is a thing based on a lot of antennas, but it works just as well for 3. I mean, it's an optimizer, and I just can't remember the stupid name of it. I wish I could, but anyway, it's out there. I know it's out there. Stay away from the IEEE. They'll make you spend $40 for an article that doesn't have any information in it. They're really, the IEEE articles are brain teasers because they usually leave out about half of what you really want to see, that the abstract seems to promise you. Anyway, that's only griping. So then right now I'm engaged in finding out the use of the Wiley Arduino Mega for multiple RS-232. And I can tell you that the RS-422, there are TTL RS-422 to RS-232 TTL level boards out there for about less than $10 a piece. So 2 of those will hook together 2 RS-232 devices at a very long distance. And they work very well indeed. I'm doing that. And what was it? Wolfgang, there's a Chinese clone of the Adelm Pluto that has a wired network connector built in, and it's reasonably well done. It's on AliExpress, and let's see. You can also, with the Rev C Plutos, you can also put in a 25 megahertz reference, a GPS reference. And that works very well too. So that I picked that one out quite some time ago instead of the B210, which I gave away. Anyway, everybody have fun and stay on your feet.
All right. Thanks, Don. And And by the way, we got our first pulsars using your B210, so thank you very much. Okay, I think that's everybody. Anybody else have any comments? I miss anybody?
I have one more comment on the book that Bruce talked about, the Krauss book. I just did a search. I see a lot of different copies of it out there, but it's like the spiral book. I have the same one. I bought it directly from Krauss's son myself, and I bought it. I don't know where Bruce got his, but I'm not finding the citation of how you order it. But he's the one that was publishing the book after his father passed away, I guess, and responsible for it. And he sent several other little items with it, with the book, which was kind of nice, I thought. And so if you're looking for that book, you might try hard to find him as a source for your book, but you can get them on Amazon too, I think.
Right. Make sure if you're buying a used one, make sure it's a second edition.
Right.
All right.
I have a question about, I saw on the online discussion, someone referred to fake SDRs. How does one spot a fake SDR? They said that they had bought them in, I guess, online, and they don't work at all. Does anybody know about this?
But I think there are some clones of the original ones. For example, there are clones from the Hack RF, and we have some experience with that specific one. The Hack RF clone does work, but it had a lot of spurious lines, and we had some problems. We had to patch or upgrade the software. We don't have any other experience, hands-on experience with clones. I understand there's one device which is sold, which is a fairly recent one that was also mentioned in the Sarah news in the group. That could be programmed to be either a B210 clone or a Ada Pluto clone, and it did have a network interface rather than a USB interface. I can't say anything about it. Typically, you will find that they copy the original design, which sometimes is open source, so it's easy to clone or copy. The question then is, are they using the same high quality components, and are they aligned and so on? They can work. It's always sort of taking a gamble whether they work good or equivalent to the original ones. Difficult to tell.
Okay, that answer your question, Wendy? In other words, it's cheap enough to buy one and roll the dice, I guess, is the question.
Yeah, I guess I would say sort of, and thanks, Wolfgang. I just thought that that a miracle would occur, and someone would say the Amazon product from the fly-by-night island of Dominican Republic is the fake one. Don't buy it, but I guess you just have to take it one step at a time.
Or just buy them from the OEM. Buy them from No Electric or AirSpy. Buy them from the manufacturer.
Okay.
And last one, Ted, you showed some pictures of shelving. I don't know if you can actually show those. There you go. Look at Ted's picture if you don't have it.
This is a picture of my dreams. This is a picture from QRZ with a guy that has racks and racks and racks and racks of ham gear. And I just thought it was a fun background. I give credit to the guy. He's up Minnesota, top of Michigan, something like that. And I don't know if he's still around, but he has been collecting for a while. Now, of course, this is the final room. He's got garages and basements full of all this stuff. Tremendous amount of equipment. It's impressive website just to go look at. So I advertise it.
I think the other thing to note is there's probably a hallway behind these shelves potentially.
Not in this case. I think these are just mostly display. But if you put all this stuff in a rack like he has in front of him, oh my gosh, how do you do the wiring and all this other stuff?
Yeah.
So I'm not a real fan of racks. I think you'd rather have shelves so that you can reach around. Yeah. If you're going to set up a permanent station like this, then a rack makes sense, it seems to me. A rack means don't touch the wires.
Right. And I have seen Ray Uberekin from DSES has a similar setup, not this big, but he can actually walk behind his shelves, and that's where he has all the cabling. So I think that's essential. Yeah.
Absolutely essential to be able to get at the back of it.
Right. And it's not reaching behind. We can walk there and actually do stuff.
I think
that's the right way to do it.
Stuff, though, is going to be
Agreed.
personal.
You have to be able to reach the rack, the back of the rack.
It's going to be personal preference, though, about what you want and how you want to arrange it. But I've got the two 19-inch racks. They roll around. I can roll them out, do whatever I need to the back of it. I built a wooden box on the side of it that has cables all in it, so I can open the door of that box and get whatever cables I need, because you always need different cables. So I've got two of those boxes. I added drawers, added a flat table that pulls out so you can put something on it you're testing in front of you and work from the rack. I got a power supply at the bottom of each rack that's wired up to the middle of it, so you can program whatever voltage you need for current limits. So it takes a lot of time to put all that kind of stuff together, like that man in the photograph with he's probably never operated on the air because he's constantly building stuff and wiring it up. It just depends on what you like.
I've got an odd story on a rack. If somebody's got I'm going to go ahead and run it by. When I was working for EMR telemetry in the 1970s type time frame, we had a big system. It was a satellite ground system that was going to a company in Germany. We were running way behind on shipping. So everybody was working through their lunch break. And well, somebody set down a hamburger while they were working, and they lost it. And the customer was not at all amused when they received the rack full of equipment, all working properly, but there was a half-eaten, rather rotten hamburger inside of it.
I like it.
At least you know it's handmade and not robot made. Okay. All right. Anybody else have anything? All right, I'm going to go ahead and post. I'll tune this up and post it, and we'll be off and running. Thanks, everybody. Also, don't forget about I'll send out a notice for Drake's Lounge Australia. If you guys haven't tuned into that, that's really fun to listen to those guys and see what they're doing down there. Okay. Thanks, everybody.
And so that would be coming up the end of this week. Yeah.
Yeah, that's Friday. Or Saturday if you're in Australia. All right.
See y'all. Bye-bye.